Hello and welcome everyone to my YouTube channel. So today I'm going to discuss about ECDSA algorithm, which is basically a key generation algorithm we basically used in cryptography. Yeah. So first of all, let's talk about what are the elliptical curves. So elliptical curves are defined by y square is equal to x square plus ax plus b, and where a and b belongs to k. So here one of the constraint is uh, 4a cube plus 27b square should not be equal to 0, and a and b are both at infinite at point 0. So some examples of the elliptical fields are rational real numbers, rational numbers, etc., and yeah, integers itself. So examples of these fields are real numbers, rational numbers, complex numbers, and integers of modulo p. See, so here are some examples of the elliptical curve graphs. So those were the elliptical curves of the real numbers, and in the complex numbers elliptical curves look like that, and this is the modulo 17. So what is so special about this elliptical curves when we come to the cryptography and key generation? So we need to make the key shorter for the mobile devices. So to make the key shorter we need this new algorithm. So given chart shows the encryption of the keys and its size in the bits. So as we can see that key size of the elliptical curves is significantly reduced, and here it shows the security node. So here more the security number, the security of the key encryption increases. Okay, so now let's understand. So to understand cryptography we need to be familiar with the group operations. So here is the definition, like given any 2 points for the elliptical curve, like what will be the p plus q. So p and q points are lie in the curve. Yeah. So here we have given 2 points p and q, and we have to find the third point r, and we need to find the r such that r is equal to p plus q. So how will we do that? So algebraically, so this is the equation for the distance between the points. So point doubling is the p plus p is equal to r, like doubling the value of the point. So geographically, like center of the line, uh, So we need to find the point of intersection with the line to the tangent in the curve. So minus 2p and 2p are the mirror image of the each other. So to find the distance between them, this is the formula. So by using this formula we can find that. So s here is the slope of that given particular line, and x is the s square minus 2xp. Yeah. So now let's move on to adding these vertical points. Yeah. So this is how we calculate the vertical points value. So there is one more algebraic application which we need to be familiar to understand this elliptic curves, so which is called the scalar multiplication. So when we have a point P on this curve and integer k, so we can find a q such that q is equal to kp. So which is called the repeated addition of this given point P. So this type of functions are called a one-way function. Like given the original value of this function, we can after giving the encrypted value, we can't give the original value of those file or whatever. So these are the scalar multiplication is the one-way function, you can't revert it. Suppose we have given this and that q is some multiple of this p. So using the elliptical curves we can find a k such that q is equal to k times of the p. So it is a very hard to solve. So this is the fundamental principle between the elliptical curves. So the final step to this is the base point generator. So G is the based on the point that generates the cyclic group. So we can reach there by repeated addition of the G. So is nothing but a size of the subgroup. Here cofactor 1 is the ideal for the case. These are the public information which are available to the everyone. So P is the field modulo. So A and B are the curve parameters. These AB and P, they both define with the generator point, they defined out the curve, and the N is the code of the G and H is the cofactor here. So let's go to discuss what is the Diffie-Hellman protocol. So Bob and Alice, they both want to communicate with each other. So how they will do it? So anyone can intercept their transmission, right? So so they need a key to encrypt and decrypt their so decrypt their messages. So here Eve is the eavesdropper who wants to hear the message. So their key should be confidential. So how this Diffie-Hellman protocol can be useful to generate the keys? So each party will be aware of the domain parameter P, A, B and G. So Bob picks the random integer beta, so which is 1 and greater than 1 and less than n minus 1. After that he computes the its new key like beta times of the G generator. After that, yeah, and Alice picks her private key at the same time like alpha, and he computes her domain. He computes the domain and it's alpha G. And after that Bob and Alice will swap the points with each other. They both interchange their key and they multiplies by each other like Bob with alpha and Alice with beta. So they generate a common key which is P, and they can use this information to communicate with each other how they wish. So Bob and Alice can communicate together, but in this case eavesdropper we they can't imagine the key, so they can't know the communication between them. For example, so we have given this curve and we need to implement the Diffie-Hellman protocol here. So how can we do that? So we can generate a simple group from this given structure, and given the generator like 5 1. So we can't use our own curve equations, so we can just use only already proved curves itself. So let's consider a cyclic group with the generator key given. So first of all we need to compute 2g like add the generator keys of both of them, so G plus G. After that what we can do, we can after given the formula 3g xg square plus a upon 2y, so we put the values in this formula and find the slope of the tangent. So with the simple Euclidean formula we can find that the value of the s. So after we find the value of the s, we need to find the mode of the 17 modulo 17 value we have to find according to the given question. So that is the method here. similarly we can compute the x2 coordinate like s square minus 2xg, and again find the modulus 17 for that. So like that, find the y and all that, and again find the modulus operation. So like that we can find the second point on the curve given from the first point location coordinates. So after that we can similarly compute the numerous amount of points on the curve. So this is the points we can compute. If we if we find out the number of the points in the group, so it is 19 and cofactor of this is 1. Now we can again implement the key exchange protocol. So consider the Bob and Alice want to communicate, and they don't want to discover the eavesdropper to know the secret key. So generator point and 19 parameters are there. So first of all, Bob picks his private key beta is equal to 9, and according to that it computes the generator. So B is equal to 9 times of G. Similarly, Alice picks alpha as a secret key as a alpha is equal to 3, and A is equal to 3G. So Eve picks A is equal to 10.7, and B eavesdropper collects the B as a 7,6. So we can see that whatever the communication is going on between these two, eavesdropper can't know the communication clearly. So this is how Bob and Alice both have the same information, but eavesdropper can't access that information. Yeah. So now let's go to the real world example. So in the real world, what we calculated till now was just an example, but in the real world these generator keys and parameters can be very large to compute manually. So we need a very high computational power for that, and most of these computations are done on the server side, like on the cloud computing. So the local public don't have to face with the high computation power issue. Thank you.